Hi again. Another weird problem. Let's see what happened here. The 10-pound weight. This is the weight. 10 pounds. It's supported by a cord AC. If it's supported by a cord, there's only one possibility here to be a tension when I do a free body diagram of this particle. And then you have a spring here. I'm going to call this F, this force here. I have the stiffness, and I have the unstretched length, which is 12 inches. Determine the distance d, so I don't know this, meaning I don't know the angle in real life. That's my unknown here. It looks like you have a bunch of unknowns, but you don't. You're gonna see that you have sufficient equations to solve this. But let's start working with what we have. I mean, what do we have here? In reality, we have three equations. The thing is that you haven't realized that we have three equations, but we have three. The first two equations, you know them, summation of forces in x equals 0, and summation of forces in y equals 0. And the third equation, you also know it, which is force equal k times s. So we have three equations that we can use for solving this problem. Let's start with summation of forces in x equals 0, assuming positive to the right and up. If I do that, basically in x, I'm going to have negative t plus this component. This angle is theta, this angle is theta, so it's going to be basically f cosine theta equals 0. And this is one equation. If I do summation of forces in y equals 0, then I have this component, f sine of theta up and 10 coming down. So f sine of theta minus 10 equals 0. And I have a second equation here. But remember, we have this, and we can make use of that. Because if I keep like that, it's impossible to solve, you know. I need something else. I have 1, 2, 3 unknowns. The angle, the force, and the tension. But once we include this equation, we can say that the force of the spring, this force, is going to be equal to k times s, which is the stretching. K I know, and what is the stretching of this? I have the unstretched length. Unstretched length is 12, and I have the final length. This is the final length. If this is the angle and this is the final length here, I can say that my hypotenuse, let's say that I use cosine here, I can say that cosine theta is equal to adjacent divided by the original length, or the stretch length, L. Let me put here final length, this one, final length. So I can calculate my final length as 12 divided by cosine theta. And my original length is 12 inches. So the stretching, this stretching will be the final length, 12 divided by cosine theta, minus the original length, which is giving us 12. That will be the stretching. That means that the force can be the constant 10 multiplied by the stretching, which is 12 minus 12 here, divided by cosine theta. That will be my force. And now what do? Well, we can work with all of the equations that we have together if we want to, or we can Yeah, that's what we have to do. We have to work with everything that we got here. Um, I can put this, whatever I find the force, and then everything will be just in terms of the tension and 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 cosine theta. So let's do that. I'm gonna put this. No, I'm gonna put this. I'm gonna put this in this equation. If I do that, then I'm going to have sine of the angle multiplied by f, and f is this, 10, 12 divided by cosine of the angle minus 12. That would be basically this, right? Sine of the angle. This would be f. This sine of the angle will be that sine of the angle. This f will be that f. Minus 10 will be this one, equals 0. And the only thing that we have to do now is solve this problem. And this problem can be solved just trial and error like we have done in the past. I'm going to put this equation in my calculator exactly as is. I don't even have to start working with multiplying, dividing, or whatever. And then I'm going to start guessing for the angles. How do you do that? Okay, let's go here and let's try for you to follow me. I'm going to code for saying something that equation. So it's going to be sine, and I'm going to start with an initial value for the angle of, let's say, imagining theta is 0 degrees as original one, which is impossible, but just for trying and see what value I should get 0. If it happens that this theta equals 0 is the value, I should get 0, right? So that would be really impressively lucky if that happens. So let's put the equation. Sine, I'm going to put 0.00 multiplied by parentheses, parentheses, 10 times parentheses, 12 divided by cosine of the angle, cosine of 0.00, close the parentheses, minus 12, close the parentheses, close the parentheses, close the parentheses, minus 10, and that should be 0. And I got negative 10. So that means that obviously that wasn't the value that I needed to get. Now let's try the angle equals 45 degrees, because I should get 0 according to this. Now let's try with 45 degrees. You go up and you go to the left, to the left, to the left, to the left, until I find the cosine, sine 45, and then cosine 45, enter, and then I get 25.15. That means that between this negative value and this positive value, there was a 0 crossing right there. For this value, if you plot the equation, you're going to find with theta equals 0, let's say that we plot it like if it was a linear equation, which is not, but let's say that we make a quick plot like that. For 0, I'm going to have here negative 10. For 45, this is 45, I'm going to get here 25. Meaning, somewhere along this line, there was a 0 crossing, which is the one that I'm looking for. So let's try, I don't know, 30. If I try 30, I just have to go up. And I always try to go to the center every time, kind of. So I should go here to 22.5, but I know it's going to be closer to 30 than to 22.5 because of the numbers that I'm seeing. So let's try here 30. And let's try here 30. And then I get negative, look at that, negative 0.72. That means that is bigger than 30, really close to 30, but smaller, of course, than 45. So what if we try 31? Go up. And we can do this as close and as perfect as you want it to be. I told you, by the way, a lot of computers work like that, and they look for the point at the center of the time until they converge into the solution. So I'm going here and I'm going to change now 31. And for 31, I got 0.3. That means that my value is between zero point 0.3 and negative 0.72, but it's closer to this one, as you can see. So I'm going to try theta equals 30.7 and see what happens. I'm just going back here to wherever I put the angle. There are some calculators that you can keep the variables, and it's easier. 30.7, and I'm going to put here 30.7 as well. And then you get negative 0.014. If you wanted to make it, better, it should be between this value and this value, closer to 0 to 30.7, so maybe 30.71, 72, but I can live with this value. So this could be my answer, because the error is really small compared with what I was supposed to get. 30.7, and if I need the distance d, which is the other thing that I need, I know that tangent of the angle has to be equal to d divided by 12. So d will be 12 multiplied by the tangent of 30.7. 12 tangent of 30.7, d equals 7.125 inches. What will be the answer? The answer will be d equals 7.13 inches, let's say, and the angle will be 30.7. Is that a difficult problem? No, it's not. But you have to start thinking, engineering, not only math, focusing, changing the values for whatever you have, and using math to help you, not to distract you from the solution. Cool. Thank you for watching. See you in the next video, guys. Have a good day.